Hello everyone, this is Ray. Let's see if anyone's watching. Okay, so we are building the dice, which is a very small, see, the size of my hand, very precise, hopefully very fast 3D printer, and my new tagline for it is the 3D printer that could. I'm quite happy with this idea. So, yesterday we were building the XY stage. I got a lot of work done with the various belt paths that had to happen, and then the flanged bearings, which come on all the sides, and that's how the belt travels. And then we also prepared the other plate that will go like this on top of it, essentially. Whoop! See? Uh-oh. Okay. So, good things to note. We do not want to slam the spindle. It's very sensitive. We have to hope that we didn't dent it or anything. And it's preferable when all the items remain on. So I guess we're good there. Okay. Cool. Right now I'm just going to find the appropriate instruction video and I can follow along. What we're going to be doing, I presume, is attaching the two pieces or plates to each other. We can see that there's these blocks here, the machined aluminum blocks, and there's also receiving holes here in all the corners. So that's something of interest. Step 9, combining the XY plate. I believe this is applicable. So for step 9, it seems like we're going to be using M3 by 8. I'm off frame here. Let's move this over here. M3 by 8. It's something of a button head Torx. Video says M4, but the sheet says M3, and those look more like M3s. No, sorry, my mistake. M4 nuts and the M3 screws. Yep, we're good. Subtitles are fun. Okay. What I didn't have on hand yesterday, but I do today, is GT2 pulleys. You can actually use whatever kind of pulley you want. Here, these are just, cheap AliExpress, I don't know, 50 cents a pop. GT2 pulley, 20 teeth. a 5mm bore, and it's going to slip on to our motors in a very, very specific fashion, I might add. So it's not like I'm just going to do this right now. But yes, 2 pulleys. So this track is ready. Yes, if you are watching, please say hello in chat. And then yesterday somebody literally writes hello in chat into the chat box. So that was a nice amount of sarcasm. We'll see if that person has shown up again today. Cool. So, one of the things that we're going to be dealing with shortly is choosing the mounting direction. There's a very specific way to do this, which I will know after continually watching the video. But in short, these bearings on this side are high up, and then these are kind of in the middle. So we're going to be aligning the pulleys accordingly. And actually, I'm not going to watch the video because I have a screenshot that will show me this. Woohoo. So, this sheet, when it is upside down from present, will be the very top of the machine, and all this stuff that's currently going up is going to be facing down. Then, this will mount accordingly. This will mount accordingly like so, and obviously there will be no space for air when this is done because of how tightly packed everything is. This set of belts is at the top. One second. Yeah, so these sides match up. And this set of belts is in the middle. So there's a case here that this motor here is going to have its pulley facing, I don't know how to describe this, the outer side is going to be facing out because this needs to stick out more. So we'll do that. And I will prepare a properly sized hex bit. And by prepare, I mean just find it right now. That'll do the trick. And I have no idea what the actual distances are going to be, so I'm just winging it right now and just very lightly tightening one screw onto the flat of the motor shaft. And then we can adjust everything later. Cool. Alrighty then. Now we go back to watching the video of the spoken German with the English subtitles. It seems like right now we're talking about where to put these M4 4mm spacers. No, we're still talking about the pulley positioning. Wonderful. I know how to find out. I'll be changing the height later. Easy peasy. Okay. So now, okay, got it. So the important things are that the belt loops here, these ears, are going to go around the motor pulleys, which we have enough slack to do that. And then there's 8 screws here where the bearings are on, and we're going to be, these are all going to go through. So I had a sneaking suspicion that there's going to be a nut first, but no. They're all going to go through the holes. So with that said, we can begin. And this cable's just got to get out of the way, essentially. Okay. That may or may not be some. Okay, 2 vaguely clicked. Two more. Two more. And 2 more. And then the first 2 popped out. Awesome. Yeah, we don't want to bend anything, presumably. Also, there's the fact that I really screwed up the hoses, or the tubing. That, yeah, there's no way that it's, you know, cut at straight right angles and accurate. So obviously, it's going to be a lot of fun. So we've put it on. Like tiny amounts of it, of those M4 screws sticking out past the surface. So we're going to be tightening this down, and that's going to compress the hoses somewhat. I don't want to lift this whole thing up right now, but later I'll show you. The Z motor, it has a little bit of clearance, so it's not, you know, that's that. So now what we're going to do is the 8 screws into these blocks here. I wasn't over tightening before, but after I do these, now would be a good time to start tightening. I want to start all 8 first. Cool. So everyone who's joined the stream, welcome. Please say hello in chat. We are currently doing the exciting part, which is almost completing the assembly of the 2 halves of the core XY stage. This is where all the XY motion happens, and conveniently the Z screw is also here. So literally, from a mechanical standpoint, all the motion of the printer is off of this section right here. And the rest of it is just a frame for stability. Which is really cool considering how little space, well, you know, there's space inside here, but it's all properly engineered. I'm sure it'll get tighter and worse. No worries. Now I'm going to go in a diagonal or a cross fashion and start tightening these down, you know, incrementally. Cool. Now, a note on thread locker. We did use Loctite when we were putting screws into stainless steel plates like the various ones on the XY axis. However, right now we're putting screws into the blocks. And the blocks are made of aluminum, which in theory should resolve itself. Hey, I just realized something. Now I understand why there's two pulleys. One moment. Yeah, let's take this whole thing apart. I'll explain why in a moment. There's two pulleys here because the motor has to make this right angle to go around the motor and then come back. Alright, let's keep going. Now I'm just going to grab the T10 bit out of here because Harbor Freight screwdrivers are easier to turn. This should be it. Yep. So yes, it's good. We're taking our time. We're making all the mistakes possible, which is great for education. You know, this is how you idiot-proof a user manual. You get someone like me to build a thing, and we note all the assumptions and the mistakes and whatnot that I make. And I'll do some really screwed up stuff, I can promise this. So, this is a good exercise. Okay, 7 screws out. Eight screws out. Okay, I have to pull this out now. And I have to do this because, do you see how my loop goes all the way out here? This is wrong. It's supposed to go like this. And this is the result. And now this loop will go around the motor. So, out and in, like so, and loop. Now we get to put this whole thing back together. That went together a little easier, I think. Cool. And now we get to start the whole thing again. So let's see, randomly, completely, I'm just doing outer screws first. Just kind of getting them threaded. Not even touching the surface. No particular order. What I was saying earlier is we're threading into aluminum right now. And aluminum is a softer metal, so I've been advised not to use Loctite on any joint that goes into aluminum. Cool. So that's 4. Now we'll do 5, 6, 7, 8, the inner ones. Start tightening these. And yeah. Even if I finish this successfully and you know, we get these motors turning, it's already a good step. It would be, yeah, we could just set this aside as the semi-finished project that it is. You know, the over $1,000 3D printer that Ray only put a third together of. It's okay. That would be a good first start. diagonally going and making additional loops and tightening. And now, assuming it doesn't completely fall apart after I do it, I feel comfortable flipping this thing 90 degrees. Crushing the belt a little bit, but now I'm going to go tighten from the bottom side, or what will be the top side. There you go. Also taking this opportunity to push all those M4 screws all the way through. And now we can use our good fresh paper towel here to do this. Wonderful. We can also put it this way. We can pull the belts and we can look. We can definitely see, I don't know how well you guys can see, but we can definitely see some stuff. This is going to need to go towards me a little bit, and this one is going to need to go away from me a little bit, but they are pretty close for what they are. My mouse is spazzing out, hang on. What I get for trusting that a mouse can be farther away and still work. There we go. Practical. Hello, Chris. Greetings to you, my good sir. Andrew, hello. So, you guys have come at the point of, we just assembled the two halves of the XY stage. Lots of fun. Jeffrey, hello. Your magnifying glass. Yeah, you know, that magnifying glass is called me holding it up to the camera and waiting for the image stabilization to kick in. So yeah. Dice printer, never heard of it. Yeah, you have to Google for it. Dice 3D printer. That will take you to the Instructable. And if you want to see the very latest, then go to well-engineered.net and you'll see some of the later updates with things like the new Cohesion 3D control board that's being used inside it, which I make. And then he's also done some water cooling on it. It's really cool. The designer's name is René Girac. Designed in Germany. I hear the sheet metal has been made in Switzerland. A lot of fun, and Chris says it's 20-sided. I agree. If you count up all the sides, 20 is low. What I'm doing is I've got a screen off to the side here where that Instructable that I talked about, if you Google Dice 3D printer, there's a series of YouTube video guides. And yeah. Okay. So right now I'm observing the instructions for the M4 screws, which are here somewhere. Yes. The M4 screws. Yes. Yeah, 20-sided humor. 1, 2, 3, 4, 5, 6, 7, 8. Cool. So we're going to be using 8 of these very, very much shorter than normal M4 screws. Let's see if that image stabilization works. It does not. Okay. And we are hopefully not bending anything. Ooh, I'm bending stuff. Not good. I think this is bent. Hang on a moment. Where's my ruler? Yeah, the ruler, great way to assess flatness. Let's look. Huh. Yeah, this is just a very complicated 3D printer, which I thoroughly enjoy. Yeah, it's bending a little bit. I have to loosen this up. How many hours have you put in? We've been doing a stream almost every day this week. So, you know, a couple of hours in the evening. Lots of fun. Andrew, 200 millimeter by 200 millimeter. Yeah, so the outer dimensions, it's a 200 millimeter cube. The print area is 100 millimeters or less. So the bed is 100 by 100 millimeters. And then depending on your usage of binder clips, you might even be cutting that down a little bit more. Yeah, this isn't working. Okay, let's wing it. I'm tightening everything. I think there might be more opportunities in the future to compress this, and yeah. We're finding all the ways this will go wrong. On my dime, so it's wonderful in that case. Tighten the second time. Hey Chris, Torex bits are good at notch stripping, right? Or rather the screw heads for Torex. Good for notch stripping, no matter how much you abuse them. Is that the general idea? And I'm confirming that even with the tightening, we should be getting spinning on the bearings. And we are. And now for the fun part. I'm not thread locking this yet. I'm just going to put the M4 screws, or the M4 nuts on here. There's one. What we will want to do is put some thread locker on here and not over tighten them. Just, you know, finger or fingernail tight, as in my case. That's all I'm doing right now. I'm just getting them on there. And the Torx, yeah, Torx, T-O-R-X, that one. Torx. Torx, yeah, that's the one, I think. Truck with more letters. That's the one. Yep, just barely. That's engaging the right amount. I see, yeah, we're good here. Cool, okay. Continuing to watch. Check that our motion is still good. There is motion. That's a good start. That could be smoother. We can readjust later. Pull the ears out here. Bent ears, as it were. Okay. What did it cost? A lot. I think if you check the BOM, the raw prices for all the materials were about €1,000, so maybe like 1,200 bucks for the base model. Water cooling the whole thing adds hundreds more, or adds a few hundred more. There's like another $250 for the tiny little radiator so that you could water cool the stepper drivers and the hot end. So lightly tightening. So he's using a wrench and just kind of barely getting in there with the driver. I just finger tightened for a while, and I like to verify everything before I go back with the Loctite. Just enough to put it in. I'm going to pop up now. Yeah, our motion's good-ish. Good. Yeah, it's good. Woohoo! Okay. Oh. There's a matter of also watching as we tighten to see that we're not making the sheet crooked or warped. Yeah. Wonderful. And there's the axis turns. Okay. Next one involves gluing the belt in. This is a lot of fun. Let's watch. At Practical Printing, I love how you are a mod for everyone. Yeah, Chris is a trustworthy person. Helps to know people like that. Everyone loves Chris. Yeah. Okay. So step 10 is wonderful. It involves gluing the belt in. Yeah. Guys, how many printers have we had where your timing belts get glued in? Well, there's our answer. Chris says, haha, it's just so I can work from home, so often available to jump on. Yep. Cool. So we're going to be using super glue, and we're going to be doing it at a later point in time, not now. The idea with the belts and the gluing of the belts is as follows. Okay, so this is a printed part, not a pressure part. A printed part. And this goes over the, wait for it, goes over here. Okay, so there was a carriage, so there's the rail, there's the carriage, and this slips onto the carriage in a way. See? On the carriage. And there are 4 holes. This is symmetrical. Hole 1, hole 2, and then you flip it, it's all symmetrical, hole 3, hole 4. Or rather, I guess, mirrored in the sense that no matter how you turn it, it's all in the same place. So, when you put this on, we're going to be putting one of the 4 pieces of belt, because this belt here is just zip tied. So I could, when I'm ready to do so, I just pull these apart, and then we have 4 ends of belt that are all going to get glued in. Also, a third party, someone else who built this machine, has a few helpers on Thingiverse, and one of those is kind of like a block with fingers or something like this that holds the belts in place while they get glued in. So this is also good. That's going to need some cleanup on the inside there. Just kind of file out the inside. Cool. Let's see if we can do some other stuff. Yeah, so let's put this aside for a moment. Hey, come on. Yes. Okay. And earlier today, I was looking at the actual print bed. This print bed is warm casted aluminum, which is extremely flat. And it's 100 by 100 millimeters, and I believe it is 5 millimeters thick. So this is extremely, extremely flat. Woohoo! Cool. And there's a few things that we need to do. One of the things is this is our Kapton heater for it. And one of the other things is this is a 100 by 100-ish piece of Filaprint. From, I'm guessing it's from Filafarm, which is .de, so I'm guessing it's a German company, I believe. Anyways, this has adhesive on the back of it, so as you would with larger PEI sheets, you would remove the adhesive and glue it onto your surface. And that's so that, you know, when you have a larger print, let's say you have a 200 by 200 millimeter bed, it's not so like at the corner it'll start lifting and you'll have a bowed piece. Here, this is small enough that we can just do this, and we can put the binder clips on 3, 4, 20 sides. Not 3, 4 sides, and it'll hold in place. Another important thing you notice, I'm keeping this in the bag, you do not want fingerprints on it. It completely ruins the adhesion. So just, if that happens, immediately wipe with alcohol or, I don't know, other interesting chemicals So yes, is the idea. So attaching the Kapton heater to the plate, that's one thing. We also need to do the screws. Okay, so assuming I'm going to do this wrong. Okay, so this one side has pockets. These pockets mean that we're going to put the M3 screw through here and the head is going to sit inside the pocket so we have a flat surface. And I tried tapping the bottom, and if that doesn't work we can also use some Loctite and glue the head in. Those are our options, probably some combination of both. Cool. So now, this would then be the bottom of the bed, and we can remove the coating and clean the surface, and then we can put the Kapton heater on like so, so that the wires exit out towards the rear of the machine. He says, okay, I need to get back to work here, good luck with the build. Thank you, Chris. We'll fail miserably with or without you. That's another one of my attempts at humor. Thank you. Okay, so there is adhesive on here. Wonderful. Cool, cool. Okay. Right now I'm just thinking about what to use to clean the surface. WD-40 is not the sort of thing we want to be using. I'm trying to think where I have alcohol. Yeah, this is the print bed, Jeffrey. It's very small. It's 100 by 100 millimeters. Here, 10 centimeters, 4 inches. That's a 10. Woo-hoo. I need to see where I keep isopropyl. Apparently, it's not here. I might have some downstairs. I'll definitely have some downstairs, which means I'm going to need to run and grab that. I'll be back in a minute, people. Whiskey works well. Yeah, so does this thing called white gas. I'm not sure what that is. Yeah, I'll be back in a minute. Back with the isopropyl. Okay. I'm sure we can find a somewhat clean section of rag if needed. We'll start with paper towels though. So I'm going to pull this. Oh, I can put on gloves for this too. Oil gloves. Not oil gloves. Nah, I'll just wing it. So surface coating coming off. You can see these lines. I have to get it so the light reflects just so, but you can see the lines. And I believe this is a CNC planed, which means you have a spinny bit that comes across and mills this extremely flat. So yes, flatness is good. Even on the bottom side. Alright. You know you've been doing this long enough when you do that and more alcohol ends up on your finger than on the paper towel or the print plate. Well, it does evaporate fairly quickly. Yeah, I don't like the streaks. We go do more. And we give it an extra minute and we see what happens. I think the 70% that's the alcohol is evaporating and the 30% that's the water and other stuff is staying put. That's wonderful. Yes, I'm sure whiskey would work well. I like whiskey though, this is a little cheaper. Cool. Alright, let's do this. So, we have this on the bottom. We're going to be pulling that off in a moment, and all we're really doing here is, it doesn't have to be perfectly centered, but we're going to have like 5 millimeters on each side to work with here. This is thin. Alright, let's get this done. Oh yeah, so you can actually see what I'm working on is I'm trying to get the adhesive starting to come off. There we go. Here's the bottom of it. The black sections are where the thermistor is, the middle one, and then the outer one is where all the wires are. Terminated, if you want to call it that. And then we'll just kind of line everything up like so. And there we go. Naturally, my work is always somewhat crooked, which is exactly how we want it, but yeah, that's my signature. But yep, that'll do the trick. Got the alcohol, may as well wipe the top of this lightly. Cool, cool. Cool. Alrighty then. And now we leave this to set for a moment while I continue to watch the video. And I think we're going to be dealing with those mounting screws next. But yay, no bubbles. That's usually good news. I'm going to try not to accidentally grab the isopropyl instead of my water when it comes to drinking. Okay, I'm going to consult the CAD model to see what size screws we might have here. And it seems like we have an M3 by 20 screw being used. And let's see if I can find such a thing. Schlitzmutten. M350, M316, M340, M320. There's 4 of them. Let's consult our chart. Zylinderkopf. Zylinderkopf. Well, cylinder sounds like cylinder, so this makes sense. So, cylindrical head M36, cheese head M316, M320. 3 used for mounting the print bed, M3 by 20. Woohoo! This is good. Let us make sure that it is indeed the correct stat. Mounting the print bed. Just watch this video a moment. Okay. First, we get 3 of these screws. I want to see if it will thread or not. So that's a 1.5. I want, actually that's a 2. I want a 2.5. Okay. Let's see what we got. Yeah, that's not threading so much. That's just right. It's going clean in. Or clean through, I should say. So, we are going to be gluing this in. And it's blue Loctite. If I screw it up, well, it's not coming apart per se, but you know. Okay, so going back up to the video about preparing the bed with a drop plate. Ah yes, so we do need this other piece. This here is the piece that holds the print bed. Right, so the brass screw, wherever he may be, this is a brass screw that goes on the Z-axis. That will sit in there, and this will move up and down. This then holds the bed. We also probably want to prop this up on something fully. This might work. Huh. Interesting. Interesting, very much. Let's check if the others are equally as tight. Now an interesting note is that I've already installed the Kapton heater, and well, because of those black cutouts, we no longer have a flush contact, which is okay. I can put a uniform spacer in. That's probably something I will do. And then we'll tightly screw this in. Yep, let's find a uniform spacer that we can use. But first, I'm very curious as to why I cannot get an M3 screw into what should be a clear M3 hole. See, that works. This does not. We'll just force the screw and it'll eventually work. That's the general idea. You know, if doing it wrong, then that's the idea. There we go, forced. That's clearing. Might just be a little bit of splurf, and then same thing for the third side here. I'm now applying pressure as I'm screwing it. There we go. See, that's going through now, and I can hopefully pull it out. Mostly moving, I presume. Might have to open it up just a touch. That's moving. That's moving. That's moving. Cool. So just a tiny bit underside. Hey, Duo. Duo says number 3. If that is the case, then my numbers haven't updated yet. So, I need a uniform spacer to use. Thinking about using some GT2 pulleys. I have spacers downstairs. I don't want to accidentally glue to a plastic one. That would be a lot of fun getting off, so we'll just use some extra GT2 pulleys. And we'll go accordingly. So, 1, 2, 3. Yeah, hey Duo, this is the heated bed. Cool. So this is warm casted aluminum. It's very, very flat. It's 5 millimeters thick, and then it's 100 by 100 millimeters. So 4 by 4 inches. That's the maximum print size we're gonna get. Kapton heater, which we've applied to the bottom after cleaning. You can probably see along the edges. You see those lines there? Very, very flat. This is like when the CNC comes through and does all the planing passes to get it very, very flat. And then the idea here is we're going to line it up with the triangle spatula of sorts. Tall. Nice. Okay. We'll just do that. Forget about this. I should just be able to use these 3 things, which are relatively close enough to each other, as kind of like lifting blocks or spacers to rest the bed on. Because right now, we're going to be gluing the screws in. Boom. And boom. Yep, that'll work. Not really, but kinda. Maybe I should get some washers, and that way it'll sit in there. Why don't we just force it? Yeah, no. I'm gonna go find a few metal washers. 1 more minute, please. I'll be back. Okay. We have a metal spacer. This is from Open Builds. It's like a 5mm inner diameter, 10mm outer diameter, and I think they come in various lengths. I think I've been using like 6.35 or 1/4 inch thick, if you will. So let's see how this would work. We have this, and we have this. Yeah, so now we're going to need to suspend the bed. Put one of these on each hole. And we're doing all this so that everything aligns properly later on. Because you can put an M3 screw through an M3 hole, but there's still room for interpretation there. So this is the idea. Joe says, quick question that may have been answered previously, how much for the whole BOM? So if you're sourcing yourself, like the raw cost is roughly €1,000, 1,200 bucks American. That's roughly where we're at. If somebody's putting together a kit for you, more. Me, I have the luxury of providing my own electronics, but other than that, Rene Girac, the creator of DICE, he put together the rest of the kit for me, which included all the metal parts, all the fasteners, a very nice power supply to which I cannot do justice. Yeah, there's literally most of the parts, excluding a few minor things that I have, like the GT2 pulleys, which I've got a box of from China, motors, electronics. That I'm doing myself. But yeah, very good stuff. For what it is, it's very good prices, but it ain't cheap. But it's awesome. Okay, so here's the idea. We have Loctite. This is a blue thread locker, 242. Rene uses 243, which is for you know, more messy applications, but we're good with 242 here. The idea is we're going to be gluing the screw by means of the head into the print bed. So not a lot. Let's see if we can do this. And if we do too much, a lot of wiping. I'm very good at over-dispensing the Loctite. Very good at that. So we're actually applying it not to the threads, but like to the underside. That's a lot. That was the lightest press I've got, and that's a lot. But yes, onto the base. Onto the underside of the screw. That's cool. Not too much. And now the fun part is to put it into the hole. And we're going to push it down. We're mostly just going to wait for it to set. That's really what this all comes down to. And if it sets, that's great, because then that's evidenced by the fact that the screw's not coming out. And if the screw does come out, I guess we'll do something else. Okay, second one. I'm going to do all three and then I'll catch up on the comments. That was more neatly applied. Yep. And now let's do the third one. Again, neat application. Just a little bit, just a little bit. There we go. Just making a little cone of it on the bottom. There we go. And yes, the idea is that this is all aligned, like that those screws are going very, very vertical and parallel to all the items. All the items. Okay, and we're just going to let that sit, and I'm going to catch up on the comment. Comment singular. So, Duo says, I accidentally used 242 for the screws holding my BL Touch in. Turns out 242 kills plastics. Destroyed the BL Touch casing and custom mount. Oh, wonderful. Yeah. The good thing you didn't use 243. The 242 and 243 are from the same line. 243 is advertised as an even more extreme version of 242. With the kind of like the notation that 243 is used for even more oily or greasy or messy environments, like the inside of an engine. We're clean, dry, and not oily here. We're gonna be okay. Also, there's the fact that like this little tube costs I can get it for like $5 and change on Amazon, but it's over $6 on Home Depot. But then 243 you can't even get at Home Depot, and the cheapest I found on Amazon was over $15. I guess it's a different size, but maybe. But still, just, you know, $5, done, that's already more than I want to spend. They make a better version for the plastic interface screws, but I didn't know about that. Good, I didn't know about any of this. I just Google on the fly. The best part is when I know to Google a couple of hours in advance. That's how I make myself seem smart, like I'm doing right now. See, all the smartness. Super glue, yeah. It's good because we're going to be using actual super glue to glue the fiberglass belts in, or not the fiberglass, the really good belts, which I don't know what they're made of. And then I'm going to go need to figure out which super glue to get that's not going to eat everything. Yeah, it contains methacrylate ester. Avoid eye and skin contact. Well then how are you supposed to use it if you're not getting it on your fingers? Jeez. Whoever wrote that? Come on. Alright, so I think the idea here is that this sets in 20 minutes and then takes 24 hours for a full cure. The idea is do not touch this, do not disturb this. We're going to gently move it over here. And I'm going to scroll through the instructables. Wow. There's like, I can count, hang on. There's 8 preparation steps that I did not explicitly do ahead of time. This included the slotted nuts and the other stuff, etc. I just ended up kind of doing it on the fly for most of it. I will still need to deal with the electronics. Electronics is getting its own everything, pretty much, as far as explanations and setups. Like, that's going to take some time. And then wire management, yeah, no. But yeah, that's pretty much it. The next step of the build, where we stopped with this thing right before Duo showed up, is it involves gluing the belts in. Yeah, so this is a build where we take our belts, the ends are here, we separate the ends, and then they end up glued into 4 cavities in this printed piece here. I'm not ready to do that yet because I have excess here. And there's a 3D printable guide, which I have not printed yet, which may be useful for holding the belts in place while they get glued in. So yes, this is one of those things that I did not realize how soon that was coming up, and I did not prepare for. Cool, cool. Flange bearings frame, XY motors, XC motors. Cool. So step 11 involves mounting more pillars. So I'll at least start explaining this, and I'll see how far we can get with it. And then that's going to have to be it for today, because I need to get information from the creator about everything I've done wrong so far. Cool. So, I will prepare the parts. One moment, please. So, blocks, and the 2 larger blocks. 4 pillars, 2 blocks. Let's clean up for a moment. PEI sheet goes over to the side. Various coatings can be put aside. This is not the robot TARS from Interstellar. It is, in fact, 4 pillars, 2 longer ones, 2 shorter ones. And then there's a series of blocks, aluminum blocks, which go in here. So there's 9 of those, and 4 were used earlier in this video in these 4 corners, and there's 5 more waiting for something else, and there's also 2 larger blocks. 4 pillars, 2 blocks. Step 11. Right. Ruler out of the way. Step 11 calls for M3 by 8, but no. M3 by 8 cheese head. Yeah, cheese head is the button variety. It's not countersunk. And then it's also calling for 4 by 10, M4 by 10 cheese head, which cheese head? No, it's the cheese head. Yeah. Button head type. Okay. M4 by 10, let's find you. Here you are. Wonderful. We have this as well. We're going to be using 4 of each. I can pull them out on the fly. Okay. This is good. Let's continue. And a knife will be used to edit the bevel of some printed part. I'm not sure. An aluminum file, and we can improvise this stuff on the fly. Apparently there's a bottle of Loctite in play as well. So, Renee is saying this is delicate. We take the long brace with the holes on the edge downward. Hang on. I don't have that. Could he be talking about the shorter one? No. Let us now consult the CAD model. Cheesehead are shown as short cylindrical head. To be very, very clear, cheesehead is most similar to a button socket head screw. So a button socket head cap. It's 4 words, B, H, C, S in some order. It's a button socket screw, and these have Torx heads, which are not easy to find on McMaster. There's a Torx security head version, but I don't know if security head and regular Torx are the same thing. I think that they're not, based on the picture. So that's that. A cylindrical screw, when I think about, is just a regular socket cap, the one where the head is actually a cylinder, as opposed to this, which is more of like an arced, weird name, but I know what button socket. Yeah, button socket caps, yeah. And because here we have cheesehead, which is the button, we have a sink screw, which is most clearly a flat screw where the head is countersunk. And then we have the cylindrical head screw, which is a normal socket cap. This is wonderful. I'm going to consult the CAD model real quick on this stuff for how to orient the beam. So I have a beam. I want where, I'll explain in a moment, I just have to think. Yep. Cool. Okay, so look. The CAD model, which is on my screen to my right here, makes more sense than the video at this stage. So we have 2 holes here, and we have an empty area here. So there's the 2 holes, and the bottom is where the holes are closer to, and the top is kind of like the blank area. If I turn it 90 degrees, these 2 holes are staggered lower than those 2 holes. See? Lower. By just a little bit. So the lower ones seem like they're facing the rear. If the rear of the machine was to me, that's the case. And the top of the machine gets the blank area. So I'm putting it like so. And then once again, to the sides, like so. Higher screw, lower screw. Higher screw, lower screw, lower screw. And oh, also the bit about lower facing. Blank area on the top. This is how it's going to get done. Okay. This is aluminum. So, per our rule of thumb, we do not have to use thread locker with screws going to aluminum because aluminum is a softer metal and the stainless screw will just go into it. Okay. So, this thing, which, I don't know, do we like this thing? It's a very, very heavy, very, very small Core XY stage. I like it. I'm going to get this started right now. So, let's hope this doesn't fall, because if this falls, that means the lead screw falls, and a lot of bad things happen because the lead screw fell. And probably got bent, and then I have to order a new one, and we're down for a few weeks, and that's all wonderful fun stuff. So, again, the rear, I have to go back to the CAD model now. Yes. The top of the machine gets the blank area. Ooh, that's a tippy. That's tippy. I can just give it a little push and that's going to tip over. Okay, so let's be careful. So the top of the machine, this is the top of the machine. The lead screw is towards the bottom of the machine because the bed is going to move down. Top of the machine gets the blank space. And then, next, again, yeah, we want the slightly lower set staggering towards the rear of the machine. Okay. And we're going to start an M3 by 8 screw into that. The Torx, it's the usual Torx. Start a screw here. You can always come back with Loctite. Lower set of screws. That's an M4, not an M3. We'll be using an M4 here. I'm going to prepare 4 M4 screws right now. Move the M3s back towards the bag. Make sure our belt is properly... Hey, this is wonderful. Both of my flange bearings inside here are facing the same way, probably from when something popped out. That's something else I'll be fixing. Wonderful. No wonder the belt does not sit cleanly in them. Woohoo. Cool. But yeah, I can pretend that all is good there. You don't have to see any of that. Okay. Yep. And that is now tipping over. Wonderful. We want to do this so that it will then not tip over. And the other side. No need to over-apply force. As the creator of this machine says, don't worry, it gets much worse. Okay. So yeah, no need to over-tighten anything, just, we'll get it done. Woohoo. So I've now done both. I mean, it's in the groove. It's in the groove quite well, I think. We're good here. Okay, now we're having the explanation of the smaller beams. This is fun. Let's talk about the smaller beams. We have... Okay, so it seems like all the holes are through holes. So if you flip it 180 degrees, you have the same set of holes that's going all the way through. Now, on one side, yeah, the translations are not working for me here. Well, I know that this is the slightly more forward area of the machine, so that's good. There's a full through on that. Woohoo. And the idea seems to be we have a hole on the top, we have a hole on the bottom. The one where the holes are lower but which way? Yeah, I get it. So similar to how we had last time, I have a hole here and I have a hole here. That leaves a large gap to the bottom, and that's lower in this case. So the small gap is going to the top, and this is going to face the rear of the machine. The lower set, yeah, I can't explain this. Bottom line, this is about to do 180 degrees, and this is about to go into it like so. And the other side, same idea. Orient as... Cool. Alright. Back to the video. As you can see, this is a huge amount of fun. Okay. Here it's useful to have a hex key because we need something that's going to get through this hole. Huh. It has to be a larger one. I don't have any Torx drivers or Torx keys. Wonderful. We're sticking with this. And improvising accordingly. Wonderful stuff. Okay. I can... Yep, this is all for alignment purposes. Okay, so. The important part is to get an M4 in here. Then get the driver in through the belts. And obviously it's not turning, so that's even better. Improvising is good, but not really. Am I going to finger tighten this right now? I'm certainly going to try. I'm using my chin to hold the lock in place. No, I'm not. I'm going to give it one rotation. Or many rotations. And the set that is higher is coming there. This is interesting. Let's put this here. Okay. I have the M3 button head, so to say, here, and the block will not sit cleanly because the edge of the head is in the way. So this is interesting. One would think that those holes are squared up. Interesting indeed. Two stacks over there. I could pull the screw. I could get a socket screw, which is lower impact, which is a lower outer diameter. now I want the set with the higher screws facing the rear. And I need a large bit. T15, where are you? There you are, my friend. I need a large bit to turn it. What I need is a right angle driver for this. Alrighty then. I can probably procure a proper Allen key and have all this fixed. Right. Oh, this is probably the chamfer. Yeah, I guess we have to chamfer an end. I guess we have to chamfer an edge off to clear the screw. So it's very precise. Yeah, I can see that his has like a nice curvature of it. Yep. So we do a mark. And we do that. Got it. Very cool. And he's using a utility knife. I'm going to consult some stuff and then bench grinder. Much more in. I don't think we'll lose too much rigidity. I want my screw back in so that this thing doesn't get loose by itself. Alright guys, I'm going to call it at this, not due to frustration, but due to there's only so many things that I want to screw up at the same time, and we've just gotten to that threshold. So usually I'll take this for about 2 hours, but we're going to end a little earlier. It's an hour and a half in right now. So thank you all for watching. I will leave the chat open for a few minutes in case anyone has any final comments or questions for me. But yeah, we'll wrap it up, and hope everyone has a good evening and enjoys their Friday and you know, all the other fun stuff. Woohoo! Ow. Oh, hey Bill. Thanks for watching. Have a good one. Okay, thanks everyone. Have a good night.